So this lesson is actually a level 3 lesson. However, I still would like you to go through this and have some basic understanding, because even though it's a level 3 lesson, you still cover this somewhat in general maths and in 2 unit. So when we're looking at areas of similar figures now, it's still looking at the relationship as a scale factor. However, now we're looking at the area and the relationship of what that means. So the summary for this is, if the matching sides of two similar figures are in the same ratio as 1 to something else, be it 1 to 2, 1 to 5, 1 to 3, or whatever number, then their areas are also in the same relationship, proportionally increased by squaring the value of k. And this I will show in an example later on. The second point is, if the matching sides now are in the relationship of mn, meaning these two numbers are different, be it 2/3, 4/5, 3/4, whatnot, then all we do is square that number, and we will then get the similar area. So the first example is using the first summary point, which is saying if the matching sides of two similar figures are in the relationship of 1 to k, then their areas are in the relationship of 1k squared. So for example 1, you should pause and you can revisit this and write it down, but at the moment you can just listen to me. And it's stating that two similar triangles have the sides in the relationship or the ratio of 1 to 5. So they're telling you the two triangles are similar, and they have the ratio or the scale factor of 1 to 5. So we need to find the ratio of the area. So we know it's in the form of 1 to k, which the k is now 5. And our second example is saying two similar parallelograms have sides ratio of 3 to 1. So now it's just reversed. Find the ratio of their areas. For the first one, we know that the given sides are in the relationship of 1 to 5. So all we have to do to that 5 is square it, and we then get the answer of 1 to 25. So the ratio of their areas now have been increased to the proportion of 1 to 25. The second point, now it's saying the ratio of the sides is 3 to 1. It's in the same form, but now the 1 is here and the k is here. It doesn't make a difference of where your 1 is. The relationship is still going to increase that k, whichever position it's taking, the first or the second, by a relationship of squaring. So I square 3 and I get 9 to 1. So the ratio of their areas now are in the proportion of 9 to 1. For the second point in the summary is saying that if the matching sides are now in the relationship of mn, meaning those two are different, it's not going to be a 1, they're going to be two different numbers, we basically square the two numbers. So for example, what is the ratio of the areas of these similar quadrilaterals shown? So first step, we need to find out what is the proportion, or what is the relationship between these two numbers. So 10 to 14 and 25 to 35, the length proportion in the ratio, we've simplified 25 and 35, divide it by 5, divide that by 5, and I get 5 to the ratio of 7. Or I could have chosen 10 and 14, reduce 10 and reduce 14. I will still get 5 and 7. We know that as the scale factors have to be the same if the shapes are similar. So I've got now the length scale factor, and I want to know what the area ratio is, and all I have to do now is square 5 and square 7. So the square of 5 and the square of 7 is 25 to the ratio of 49 respectively. So my first step is to find out the scale factor for each length, and then I just square each one individually and I get a new area ratio. Next one, two similar trapeziums have the area and the ratio of 25 to 16. Find the ratio of the lengths of the matching sides. So I'm going to be working backwards. So the ratios of the area we know are m squared, n squared, and they've told you that they are in the relationship of 25 to 16. We know to go backwards from squaring we need to square root So we're doing the inverse of it. And the square root of 25 is 5. The square root of 16 is 4. So now I know what the length ratios are, or the scale factor in length is 5 to 4. Now we're saying that two similar triangles, P and Q, have matching sides in the relationship of 3 to 4. If the area of the larger triangle is 288 centimeters, find the area of the smaller triangle. So we need to use this relationship, obviously, to be able to work out what is going to be the smaller triangle's area. So first step is draw it out. We're visual people, we like to draw it out. We know we've got one triangle called P, one triangle called Q. They have the matching sides ratio of 3 to 4. So I would just put a 3 and a 4 down. And we know that this area is 288 centimeters squared. So let's work this out. So if the ratio of the matching sides is 3 to 4, I know I need to square each one because it falls into the second category that each one is different. It's not a 1. So I need to square, and so now I have the area relationship. So it's now 9 to 16. I then put it into basic fractions, and I put my unknown always at the top because that's the one I'm trying to find out. The area of P over the area of Q. And again, I'm choosing the right number to put on top here because it's the smaller number, and we're trying to find the smaller area, so it's going to be 9 over 16. And I do the same as I previously did, and I bring that 288 over to the other side. It's division on this side, so I bring it to the other side and I multiply. And now I'm going to be able to get the area of P by just punching that into my calculator. 9 over 16 times it by 288. And I get my area, which is 162 centimeters squared. So I found out by using the scale factor of 9 over 16 what the P triangle area would be. So the area of the smaller triangle is 162 centimeters squared. So it's not a very difficult concept to understand if you know the two relationships from the beginnings to the first slide. And that's pretty much areas of similar figures 13.07. Important point is to really understand these two summarizing points, but not a very difficult concept to grasp.